What I would like to present here today is the photovoltaic systems protection from the surge protection point of view, basically from the protection of over voltage, or rather say surge protection. And we will at the beginning talk about the surge protection devices types. SPD is ogranicznik przepięć, surge protection devices types. To give you some basic info about the different types we have here. Then we would like to share with you some basics about the photovoltaic principle, of course, and the application of surge protection devices. We will go to European Union standards and some requirements and specifications so that you know where to look for information. And I would like to explain and try to explain how to select surge protection devices for your photovoltaic system and what are the requirements and configuration here. Other photovoltaic installation components that we need for photovoltaic systems will be mentioned very shortly, so that you know that not only surge protection devices but also other components come into action, and we have in Hakel those systems available. And then I will give you some brief info about Hakel portfolio, not only for photovoltaic but also for just common surge protection devices. But we will see how we manage with time. Okay. Okay, we will not show this video because we are in a PDF presentation mode. So let me start with the surge protection devices types. As you may know, there are three types of surge protection classification based on European Union Standard 61634311. Surge protection devices type 1, type 1 and 2, and type 3. I will stop on this slide. You may know the old naming, which is Class B surge protection devices, or Class B plus C or B plus C plus D in case of a T3. But to give you some more info, type 1, you shall not use Class B anymore. This is not based on the terminology already many years. So type 1 surge protection device is the strongest one. It serves here as a strongest component for absorption of lightning, very high energy pulses. So it usually is installed at the beginning of the installation of your electrical installation. So usually in the main switchboard. Type 2, I will switch further. Type 2, however, is installed usually in the secondary switchboard. And it is designed for pulses with lower energy. For example, the energy that remains in the installation after it goes through type 1. Then there is type 2, which shall absorb such energy, or induced energy, or switching energy in industry. If you have a big industry factory, for example, and there are many devices that may produce switching surge voltage. So type 2 is the second one in the stage, and very often type 1 and 2 are combined together. So you see T1 plus T2 or type 1 plus type 2. But this is valid only up to 20 meters of the installation. If you have much more meters of the wires, then you need to repeat type 2 because of the possible induced surge voltage. So type 1 and 2 is okay if you have devices 20 meters, up to 20 meters. If not, then you need to repeat type 2. And type 3 is the last one, formerly known as Class D, and it is the most sensitive surge protection device. It must be installed very close to the protected device. So if you have any electrical device that you would like to protect, any computer or any IT system or anything which is sensitive, you install type 3 very as close as possible to this to your device. It is very often combined with a filter, high frequency filter, for enhancing the protection. And we can also combine type 1, 2, and 3 together. So you can see it on the market. We also have it in our portfolio, but it works up to 10 meters of an installation. So for example, in my apartment where I live, I have just behind the door, where there is the main apartment switchboard, I have type 1, 2, and 3 installed. And I have some devices for my network in the apartment right behind this main switchboard, close to the main entrance. So 10 meters is really safe. For example, a router, NAS, a server, switch, and some other components. And all these are protected with one device, 1 + 2 + 3. If I have a television set, for example, which is further in the apartment somewhere else, which is more than 10 meters, I need to repeat type 3 and put it as close as to the television as possible. So this is how you can manage type 1 and 2 together, or type 1, 2, and 3. I need to explain those types here for you, because for the photovoltaic system, we will be talking about the types as well. What is important if you buy a surge protection device is this parameter, voltage protection level, UP. Voltage protection level is basically the maximum voltage that the producer guarantees that is behind the surge protection device in your installation. So even if there is a high peak of energy that goes through the surge protection device, this voltage protection, some level of voltage is maintained after this, after the high energy pulse, and is kept by the particular type of the SPD. I'm talking about that because this is the parameter you can look at when you select SPD. And of course, different producers have different voltage protection levels. And you can also match this voltage protection level with the withstand voltage of your device you want to protect. So each device you want to protect is basically divided into categories 1, 2, 3, and 4 of the voltage it can withstand before it is damaged. So if you have a device in category 3, for example, it can withstand 4 kilovolts if you connect 4.1, or if you have such a high energy pulse from lightning or switching, whatever, and it produces voltage that is over 4 kilovolts, your device may be damaged. The producer of the device will not guarantee it. So that if you want to protect the device, you need to have this voltage protection level lower than the withstand voltage. And as you can see, this is the blue line in the graph. Hakel systems basically protect all the categories, all the equipment, starting type 1 already. So we guarantee that if you use type 1, you will have maximum 1.25 kilovolts after this type 1 in your installation, and you will be very safe when protecting all the categories of your equipment. So voltage protection level is very important here to for example, compare or to check if you are on a comfortable level with your protection, with your SPD protection. Okay, then let's jump to the photovoltaic finally. I would start with photovoltaic principle here because you need to understand further. So the photovoltaic systems consist of some panels, modules, here as photovoltaic array, then photovoltaic inverter, which basically converts the DC current that is produced by the modules to AC. And then, of course, it is somewhere connected to your grid, to the power system you have, usually in the main distribution board. So this is the principle. You need to convert the energy, the DC voltage to AC voltage. The smallest component of photovoltaic systems are photovoltaic modules. They produce 50 to 100 volts DC. And if you combine them together, as shown on the picture on the right side, and you have a serial connection of those modules, you increase the output voltage here that this photovoltaic modules will make together, basically. So if you, for example, connect 10 modules, each of them 50 volts, you have 500 volts DC at the output, which goes to the inverter. So based on the inverter you have in your installation, based on the selected inverter, you connect the modules together, 5 modules, 6 modules, 10 modules, 20, and you create the photovoltaic string, so to say. So the photovoltaic string is based on the inverter you have, or you would like to have in your installation. And then you can electrically connect several modules or strings together, and you create a photovoltaic array that goes to one inverter, to one power conversion equipment. What is important here is the photovoltaic system safety, because you need to really remember that even if you disconnect the inverter, for example, or switch off your system, it still produces energy because the sun is still shining during the day somehow, more or somehow it's still there is a production of energy all the time. So you need to have some signs that there is a photovoltaic installation on the object, and you also need to have an information. It is written here somewhere in the text. Leaf parts can remain energized after isolation. So this safety requirements come from harmonized document 6364/7712, and it is very important, for example, for the fire guards. When we applicate or install the surge protection devices, we need to do a basic division at the beginning. Do we have an lightning protection systems or not? And is the separation distance between the lightning protection system and our photovoltaic installation big enough or not? That is the main idea, basically. So if you have the LPS installed and the separation distance, is okay, then you don't need to take care of that some energy will jump to your photovoltaic system. The distance is big enough. But if it's not maintained, there is less than the separation distance. This is on the picture on the right side. Then you need to electrically connect your photovoltaic system to your LPS. And of course, then you select a different surge protection devices. I will show it in the next slides. So this is the first case. You have on the object, you have the external lightning protection system installed, but you cannot maintain, for some reason, the separation distance. Then you electrically connect it to the photovoltaic array. You can see it on the picture on the right side there is a letter E. This is the electrical connection to the LPS. And then you must install type 1 of the surge protection devices, as we explained at the beginning what type 1 is. So usually you install 1 plus 2 because the producers produce 1 plus 2 as a very good combination. But type 1 or 1 plus 2 must be installed in such case. The second example is that you have the lightning protection system installed, but the separation distance is maintained. So you keep the distance from the external LPS and you are okay. There is no partial lightning energy risk that goes to your construction of the photovoltaic system. Then you can work with type 2 surge protection devices. You install type 2. That is okay. You do not need to take care of the lightning energy that may come to your system. Usually, type 1 plus 2 does not have much higher price than type 2. Not usually, but sometimes it does not have such a higher price. So you can buy type 1 plus 2 for extra safety, and you don't need to care of the separation distance, whether it is or is not maintained. But be careful, if it's not maintained, you need to have this direct connection between the metallic structure and the LPS. The third case, the basic division number 3, is that the external LPS is not installed at all. So you have an object, for example, a house that does not have an external LPS, and you want to install photovoltaic system on it. So there is not basically lightning energy risk, and you install SPD type 2 as well. This is enough. But again, if it's on your, of course, cost comfort, basically you can buy type 1 plus 2. So that is the basic division based on the LPS and the separation distance. So what is the process when you design a photovoltaic protection? It comes from the standards and technical specification. First of all, you need to make a risk analysis of your installation, always. This is not only because of photovoltaic, this is for all objects or for all installations. So you make a risk analysis. Risk analysis means that you take into account what is the object location, if there are any big trees around, if there are any other buildings in the vicinity, if you have the power line going through the ground or through the air, and so on. From this risk analysis, which is described in EN 62305 section 2, you make a decision, or the person that is making the project, of course, it does not need to be you, basically. So the person that makes the project, he needs to then calculate the risk analysis and decide whether the LPS, the external lightning protection, is needed and there is a risk of direct lightning strike, or it is not needed at all and there is not such a risk. If yes, then you need to design the LPS. So part 3 of the same standard 62305 is about LPS design. And then you basically jump to photovoltaic standard. This is in harmonized document 636477712, which is talking about the way of designing photovoltaic system, the modules, inverters selection, how to connect them together, and all these hardware details, I would say, of the photovoltaic system. The next step is to select the proper SPD protection. we have two standards, 61643, section 31 and section 11, that are requirements how the SPD for photovoltaic systems must look like. This is mainly for the producers like us, like Hakel, which is producing. So there is a description, what are the requirements for photovoltaic SPDs. The section 31 is about, or mainly about DC SPDs, and the section 11 is about AC SPDs in general, for not only for photovoltaic. And if you want to focus, you as a installer, for example, or the project creator, you can use this IEC 61643 section 32, which is surge protection devices connected to the DC side of the photovoltaic installations. So here you will find basically the selection of photovoltaic SPDs and the way of installation on the DC side. Let me go back because I skipped one important information for you here at the fundamental principle picture, because I was talking about the array, inverter, and main distribution board, and you can see those SPDs here. So what is important is to realize that here we have the DC voltage on the right side between the inverter and the array, and we need to install DC SPDs. But behind the inverter, so between the inverter and the connection point to the grid, we already have AC, so there must be AC SPD installed. So we cannot just talk about only DC SPD or AC SPD as a protection for photovoltaic. It basically must you need to consider all the protection on both sides of the inverter, AC SPD as well as DC. And that is why I'm showing those standards here that help you with the selection and installation. So this is where you can basically look at and follow the instructions or the requirements, I should rather say. So how do we select them, those AC and DC? The first idea is to know the voltage of the DC part. You have here some equations, but this is very simple, don't worry. So the first one, the basic one, is on the left side, UMP, which is the string DC voltage, maximum power voltage of a string that it can produce, is always lower than open circuit voltage under standard test conditions, UOC STC. And this voltage is the standard test conditions. Basically, it's on a cold and sunny day. So sunny, it produces maximum energy, and cold, it has the maximum efficiency. So cold and sunny day, for example, in spring or autumn, are the best for photovoltaic efficiency. It produces the maximum voltage. In winter, you usually do not have such a direct sunlight, so it does not have such efficiency. And in summer, you usually have high temperatures, which also makes the efficiency lower and the maximum voltage also lower. So these are the ideal conditions, I would say. And such voltage must be lower than UDC max, which is the maximum input voltage of the inverter. So you cannot put higher voltage to the inverter because you will damage the inverter. And if you want to know what is the max continuous operating voltage of your SPD, this is the orange one, UCPV. So this UCPV must be this open circuit voltage under ideal conditions plus 20%. So this is some 20% extra, we always put it here. So 1.2 times UOC is the voltage of your SPD system. So if you, for example, have an inverter that has maximum input voltage 500 volts DC, then your open circuit voltage parameter will be 100 or lower, 480, for example, and you select the SPD if you multiply 1.2 times the open circuit voltage. If we take 500 volts, then it's 1.2 is 600 volts is the max continuous voltage of your SPD you select. So 500 volts open circuit ideal conditions voltage means 600 volt SPD. So 20% is considered as an extra always in such cases. So this is the selection based on the voltage of your components. And this is where we installed those SPDs. Number one here in the installation is the DC SPD, which is installed as close to the inverter as possible, because we want to protect the inverter. This is the main and most expensive component of the installation. And this is the DC SPD we were talking about, how to calculate the voltage of it. Then number two is on the other side of the inverter, but on the AC side. And we also put it as close to the inverter as possible. If there is a big distance here, for example, we can combine 2 and 3, and we can put it here, or we can put it here on the main distribution board. If the distance is very low, we can have just one SPD. This is the same as number 1 and 4. If the distance is higher than 10 meters, then we need to repeat the DC SPD and put it as close to photovoltaic array as possible, so that we get rid of any inductions processes. But we can basically install number 1 if the inverter is very close to the photovoltaic array, and number 2 if it's very close to the grid, to the distribution board. So this is where to put it. And of course, this AC SPD here on the left side, which means number 2 and 3, are the standard SPDs we use. These are not longer designed for photovoltaic systems, because this is just standard AC power supply system we use elsewhere. So typical applications, I will show examples and show you where and what types we need to design here. So this is a family house, and it does not have any LPS. So there is no LPS installed, no external protection. And if you can see on the top, there is an inverter. So we put type 2 on the DC side. No LPS means type 2. And we put type 2 on the AC side on the inverter as well. Again, type 2. And we can put also, because there could be a longer distance, we put at the main distribution board as the main protection of the family house. We put type 2 as well, but usually, because the costs are not that big, we put type 3 at the bottom. This is the HSA 4+0. This is one of the Hakel types of the SPDs. Then an example of a family house that has LPS installed, but the separation distance is not maintained here. So there is a problem because there is a risk that the energy from the lightning, which goes to the LPS, will jump to our photovoltaic metallic construction. So we need to put this direct connection between the construction and the LPS. And we install type 1 and 1 everywhere, or 1+2 everywhere. So there is type 1+2 very close to the photovoltaic panels, then 1+2 close to the inverter, 1+2 on the AC side of the inverter, and 1+2 in the main distribution board. Then we may have a commercial building or factory that is that means large installations on the roof or somewhere next to this building. And if the LPS is installed, but the separation is not maintained, the separation distance is not maintained, then we put types 1 or types 1+2. And you can work with 12.2 kiloamps SPDs on the AC side. You may know that this common SPD are divided not only based on types, but also this type 1 and 2, type 1 or 1+2 are divided on the kiloamps they can handle of the lightning current pulse. So 12.5 kiloamps is usually okay at the photovoltaic installation, but in the main distribution board, in case of this bigger buildings, we use 25 kiloamp 1+2 SPD on the AC side. If the separation distance is maintained, then we put type 2 on the DC side, type 2 on the AC side at the inverter, and type 1+2 in the main distribution board, again 25 kiloamp usually in such installations. In case of the family house, we usually use 12.5 kiloamps. So this is how to what to select basically. And the third case are some solar parks, free area, big installations. There is usually either a central inverter, so one big inverter unit, or decentralized inverters. For example, for each photovoltaic string, there could be one inverter. So in case of this central inverter, you usually have at each photovoltaic string types 1 or 1+2, you have the DC inverters at the inverter also, because the distance between the string and the inverter is usually very long. So you have two DC surge protection devices installed. And you have one AC type somewhere, of course, on the AC side of the inverter. And in case of the decentralized inverters, so you are having them much closer to the strings, you may use type 2, because usually there is some LPS in such installations, and there is the distance is maintained. On the AC side, you put type 1 or 1+2 here in such cases. But you will probably be the most interested in this commercial building or administration building or a family house, which are the cases here. What is important is that you cannot just take any DC SPD for a photovoltaic system. You really need to select photovoltaic SPD that is designed for photovoltaic installations. This IEC requirement, this standard 6164332, is talking about that each photovoltaic SPD must have a protection against DC arc, which is very dangerous, of course. It must have either a built-in disconnector or some external disconnector must be installed in series with the SPD. The reality is that all producers put built-in disconnectors into their SPDs, and we call it basically this DC arc cutoff unit, and it also must have this common thermal disconnector each SPD contains. So common SPDs have only thermal disconnector that disconnects the SPD after it is damaged after many years, for example. And photovoltaic SPDs must have, in addition, this cutoff unit. So really be careful when you select an SPD from a producer, which are, for example, not so well known or do not have so many years of experience, or you have some cheap Chinese SPDs. They may not have this cutoff unit. So this is really, risky. It is really better to buy some well-known producer. For example, Hakel is producing surge production devices for more than 25 years. So we have very big experience. We have also these lightning generators, our own generators, where we simulate the lightning conditions and we test all these SPDs. So you really get very high quality from producers like Hakel or our competitors, which are also having high quality products. So in this case, you need to really be really careful and select photovoltaic SPD. I cannot show the videos here from the PDF, but these were the videos that show basically how our SPD disconnects, how the cutoff unit reacts, and the SPD on the right side, which is some low quality competition and SPD from a competitor, will basically burn out if there is no cutoff unit inside. So really be careful. And let me also mention very shortly that there are also other photovoltaic components in the installation, not only SPDs. We use also frequency and voltage monitors, because you need to make sure that your photovoltaic system does not produce voltage that is out of the range that can go into the power public power system. So you need to make sure that your voltage is on the right level and also the frequency. And if not, for any case, you need to disconnect your photovoltaic system. So this is a product we have in our portfolio that monitors the voltage and frequency, and in case it is out of the permitted range, it basically disconnects the system and connects back after everything is okay. There is a limit 10% for the voltage and 1% for the frequency. So this is a component that you might be interested in. And then there also are insulation monitoring devices used, because the photovoltaic installation is basically an isolated power supply IT power system. So it must be monitored by an insulation monitoring device. It is described in this 63647712 harmonized document. It's basically a prevention of fire risk, that the insulation of your system is okay. Hakel is a long-term producer of insulation monitoring devices, but we do not have insulation monitoring devices for photovoltaic. These must be certified and really produced just for photovoltaic systems, because mainly those insulation monitoring devices are already built in the inverter. So the demand of the market for external insulation monitoring devices is quite low, and we have not made a decision to certify our insulation monitoring devices for photovoltaic systems. However, I can see in Poland that the demand is a little bit growing. So if you have such a requirement and you would be interested in insulation monitoring device for photovoltaic system from us, then please contact your sales representative, and we will collect those demands. From the technical point of view, it is not a big problem for us, of course, but there is a question of the demand and certification. So this is the question of the money to be invested here. But I would just like to share with you that insulation monitoring devices are very often a part of photovoltaic installation, and very often, usually they are in the inverter already built in. So let's have a look at the portfolio of Hakel SPDs so that you know what we have. And these are the type 1, 2, 3, or the combinations type 1 plus 2 plus 3 or 1, 2 plus 3 we have in our offer. So we have not only the strongest one, type 1 SPDs, we have also type 3 with filters or going to the sockets or behind the sockets as an additional installation. We have really a vast range of SPDs in our portfolio. And we also have IT power supply system SPDs. Not many producers have them. Because we are a producer of insulation monitoring devices, then we all very much focus on the IT power supply system, these isolated ones. So you can see in our offer those SPDs specifically designed for isolated systems. And let's have a look at the photovoltaic offer we have. So we have, for the DC side of the photovoltaic system, type 1 plus 2, we have 600, 800, and 1000 voltage protectors. UCPV is the maximum continuous voltage for the photovoltaic installation of the SPD. So you can see it here. And I also marked yellow the UP. You may remember from the beginning of the installation, this was the voltage protection level. So this is the voltage protection level we achieve or we guarantee after the SPD from our production. So this is type 1 plus 2, 600, 800, and 1000 volt DC systems, which are the most common ones. Type 2 for DC sections or DC parts of the installation, we have from 600 to 1500 volts. Again, with some very good voltage protection levels here. Of course, all these have those internal disconnectors, this cutoff unit for the for disconnecting the DC arc. And we also offer here very good, a little bit special AC side protection. This is a serial combination of varistor and gas discharge tube, GDT. So this gas discharge tube will guarantee that there is no leakage current for you. And this is the 25 kiloamp. So we use it in the bigger installations like commercial buildings or administration buildings or these solar parks on free areas. And we can achieve 1.2 kilovolt voltage level, really excellent level you get after this SPD. But you can also choose common, cheaper types, which are varistor-based AC surge protection devices for the AC side, usually 12.5 kiloamps for the family houses or small commercial buildings with very low voltage protection levels in many configurations for TNC and TNS power systems. And also types 2 plus 3. Again, for TNC systems, there is a wide range of those product. I can briefly show you that the type HLSA, HLSA 12.5 kiloamp is very simply said Hakel lightning surge arrestor. Lightning, so it means that this is type 1 for sure. It is also type 2 and 3 up to 10 meters. So Hakel lightning surge arrestor is type 1 plus 2 or 1 plus 2 plus 3. However, HSA, HSA is Hakel surge arrestor. There is no L like lightning. So this is type 2. It cannot be type 1. It is not designed for lightning energy pulses. So HSA, Hakel surge arrestor. So you can easily see what type this is. We also have for the photovoltaic system some data protection, because there is very often on bigger installations some data transferring from the inverter to have some enhanced monitoring. So we have data protection units from 6 to 48 volts, many types of connections and protections. And we also have Ethernet protection for data, category 6 data protection that is used in the photovoltaic Ethernet transmissions if this is needed. So this is briefly the portfolio, because I can see that it's almost 11 and we need to be at the end of the presentation. So thanks for your attention here.